Uh, Welcome, dear student. I hope you are well. And today we will discuss about the third chapter. Our third chapter, force. About force. This is the new chapter, and this is the important chapter for you because this chapter is important because this chapter is included in class 11 and 12. Any question than previous chapter in motion? There is any questions or any problem?
Yes,
Log.
sir.
Yes.
I have a question, sir. If the question comes that a car traveled, how much distance in the 5th or 6th second, then can we use the formula u plus half a into 2t minus 1?
This is the derivative formula. This formula is not included in your books. So if you want to use this formula, you have to at first you have to derive it, then you can use it. Otherwise, you can 5th or 4th second you can say that as th equals to u plus half of a 2t minus 1. That's all. Yes or
Yes,
no?
sir.
This
Yes, sir.
formula, in MCQ type question, you can use this formula, but in creative question, you cannot use this because this equation is not included in your book. If you want to use it, at first you have to determine the ST equals to UT plus half of AT squared, and ST minus 1 will be ST minus 1 plus half of AT minus 1 whole square. So STH equals to ST minus 1. Then you can get UT plus half of AT square minus UT minus 1 minus half of AT minus 1 whole square. So UT plus half of AT square minus UT plus U minus half of AT minus 1 whole square. So UT back. So U plus half of A equals to T square minus T square plus 2T minus 1. So T square kata, then you can write half of A 2T minus 1. This is the STS. At first you have to determine this, then you can use this formula. Okay?
Okay. Yes, sir.
Okay. Okay. Now, any problem? In previous chapter, there is problem? No. Okay, come on. Now we discuss about force. About force. Sorry. Force, it is related with push or pull. Force is push or pull. If force is applied, this is the push, and this is the pull. The push or pull is a force. It can change or wants to change position of the object. Position of the object. It can change or wants to change the shape and size of the object. Shape and size of the object. Shape and size of the object. And we can say it can change or wants to change the inertia. Wants to change the inertia. Inertia means a rest body is in rest and a motion body wants to in motion. This property is called the inertia, by which property a object a object wants to the property the which property the object wants to gain its own position, own state. It cannot change. That is called the inertia. So if push or pull or force is applied, the shape, position, etc. will be changed. So that is called the that we call that it can change or wants to change the inertia. So the unit of force is Newton. In SI system, the unit of force is Newton. SI system. SI unit, that is the Newton, and CDS system, it is time. DYN, time. Okay. Force is measured F equals to MA. F equals to MA. You have to remember this. F equals to MA, where F is the force. Force, A is the mass, and A is the acceleration. We know acceleration in previous chapter. Acceleration is the rate of change of velocity. Rate of change of velocity. So A equals to V minus U by T. Rate of change of velocity is called the acceleration. So rate of change of velocity. So meter per second per second. It's called the acceleration unit. Meter per second by second, it is the acceleration. So the unit of force is Newton. If m equals to 1 kilogram and A equals to 1 meter per second square, then F equals to 1 Newton. Suppose this is an object. F equals to 1 Newton is applied on this object, and mass is 1 kilogram, and its gain 1 meter per second square. That is called the situation that this phenomena denotes the 1 Newton. Suppose we can say if what amount of force is applied on 1 kilogram object and creates 1 meter per second square acceleration, that is called the 1 Newton. That is called 1 Newton. On the other hand, you can say to create 1 meter per second square acceleration on 1 kilogram object, which amount of force is applied, that is called the 1 Newton. You have to remember this. In this case, no friction is considered here. No frictional force is considered here. It is applicable, F equals to MA. It is applicable on frictionless flow. Frictionless phenomena. Frictionless phenomena. If friction is present, the equation will be changed. The amount of force or effective force is changed. M equals to MA, it is unchanged. So come on. Now, dyne. Another is dyne. M equals to 1 gram and A equals to 1 centimeter per second square. Then F equals to 1 dyne. Suppose this is the object and F equals to 1 dyne is applied, and 1 gram and 1 centimeter per second square is acceleration. So we can say to produce 1 centimeter per second square acceleration, to which amount of force applied on 1 gram object, that is called the 1 dyne. Sorry, 1 Newton. No, it is 1 dyne. So there is a relation between 1 Newton and die. Come on. Relation between Newton and die. Relation between Newton and die. Newton and die. Relation between Newton and die. Okay. Suppose we know F equals to ma. 1 Newton equals to 1 kilogram into 1 meter per second square. Okay. You can convert it into gram. 1000 gram into 100 centimeter per second square. So 10 to the power 5 gram centimeter per second square. So 10 to the power 5 gram. So you have to remember 1 Newton equals to 10 to the power 5. 10 to the power 5 times. Okay. There are two types of force. Types of force we know: balanced force and unbalanced force. On the other hand, we can say this is the contact force, non-contact force, etc. Balanced force and unbalanced force. Unbalanced force. Balanced force, the condition balanced force is net force is equals to 0 or acceleration is 0. Suppose this is an object. The mass of the object is suppose 5 kilogram. A 5 Newton force is applied in this direction, another 5 Newton force is applied in this direction. So the position of the object is not changed. That means they have the net force is 0. Net force is 0. If force is 0, then acceleration must be 0. That is the condition of the balance force. So balance force, if force is applied, there is no acceleration state on this object. That is called the balance condition. Unbalanced condition, F net is not equals to 0 and A is not equals to 0. Suppose this is 10 Newton. In this direction 10 Newton, so F net will be, suppose this is the F1 and this is the F2. So F1 plus F2, but 10 plus minus 5, because this is the opposite direction, so 10 minus 5, that is the 5 Newton. That is the F net is not 0, so it is called the unbalanced condition. So F not equals to 0, so F equals to F net equals to ma. So we can say that is the acceleration. Acceleration will be 1 meter per second square. Here acceleration also present, so we can say that is the unbalanced condition. Understand?
Yes, sir.
There is the another two types of the force, that is the contact force and non-contact force. Contact force and non-contact force. Contact force and non-contact force. Contact force is the tension force. Tension force. Tension is the contact force. Non-contact force, gravitational force. Gravitational force. Magnetic force. Magnetic force. Electrostatic force. Electrostatic force. Electrostatic force. Contact force is the tension force. At first, we discuss about the gravitational force, then we discuss about the tension. Okay. Gravitational force. Gravitational force. Gravitational force. Suppose this is the Earth. Earth. This is the Earth. The mass of the Earth is R and radius is R. An object is placed here. The mass of the object is M. And it's attracted by the Earth towards the center. And the Earth is attracted by this object in this direction. So here the force will be F equals to G, capital M, small m, if this distance is H and the radius is R. On the other hand, you can consider that is the small r. So small r square, here R equals to capital R plus H. If the object is the surface of the Earth, this is the Earth and this is the mass of the object and this is the radius. So we can consider F equals to Gmm by R square at the surface of the Earth. Then the gravitational force will be F equals to Gmm by R square, where G is the gravitational constant. G is the gravitational constant. Come on. You can write F equals to Gmm by R square, where G is the gravitational constant, and it is 6.67 into 10 to the power minus 11 Newton meter square kilogram inverse 2. How is possible? What is the, how come the unit is? So G equals to F R square by Mn. F unit of G, this is the Newton meter square, kilogram into kilogram. So it will be Newton meter square kilogram inverse. Okay, this is the unit of gravitational constant. Okay, now gravitational force. Suppose this is the mass. The mass of the object is 10 kilogram, and this object is 20 kilogram. The radius of this object is 2 centimeter, and radius of this object is 4 centimeter. The distance between them is suppose 4 meter. What will be the force? You have to remember that gravitational force is central force. Central force means it acts to the center. So you have to consider the distance from center to center. Center to center. Okay. You have to consider the mass center to center. So here M1 equals to 10 kilogram, M2 equals to 20 kilogram, and D or R equals to 4 plus 2 plus 100 plus 4 plus 100 meter. Centimeter converted into meter, centimeter converted into meter. So 4 plus 0.02 plus 0.04 meter, it will be 4.06 meter. Then you can easily G M1 M2 by R square. Putting this value, you can get a answer. Okay. Any questions about this? কোশ্চেন আছে তোমাদের কোনো থাকলে বলো।
বুঝতে পারছি স্যার, ঠিক আছে।
Okay. It's not necessary the object always in spherical. Okay. Come on. Wait, please. the another gravitational force, there another is the tension force. Tension force. Okay, come. Suppose this is the block. This is the surface. Oh, there is a block here. This is the M1. There is the block here. This is the M2. And there is a pulley. It is connected by a spring. And this is the connecting by a string. This is the M3. You have to remember this. They are connected to each other. They are connected to each other. Okay. You know the weight in this direction, that is the M3G. You have to remember tension always away from the object. Away from the object. How it's possible? This tension is X from this object. And if the string is not changed, tension is not changed. Tension is not changed. So here tension is T, here also tension is T, away from the object. And here the string is changed, that is the T1 away from the object, for this away from the object. Okay, tension force. Any question about this? Suppose another question, another figure. This is the rigid step, and there is a pulley, and there is the object, frictionless pulley. This is the mass, suppose 2 kilogram, and here is a mass. This is the 4 kilogram. 4 kilogram. Suppose G equals to 10 meter per second square. Suppose. My question is, T equals to what and A equals to what? Tension equals to what and acceleration is what? Come on. For this, the weight in this direction, this is the 4G. Tension always in this direction. Okay. And the body moves on, the weight in this direction, this is the 2G. The tension always in this direction, this is also T. Because the spring are same, there is no change of string. So it's T and it's also T. Here the acceleration direction in this direction A, here the acceleration in this direction, that is also because the object is moving in this direction. So come on. According to this mesh, that is the M1 and this is the M2. Okay. So according to this, we can write here M1G and tension in this direction T. Here T is greater than M1G. So for first object, T minus M1G equals to M1A. Okay. For second object, the object is moves in downward. So 4G is greater than M2G. M2G is greater than T. So M2G minus T equals to M2A. Okay. Now we add them. TT cut M2G minus M1G equals to M1 plus M2 into A. So A will be M2 minus M1 by M1 plus M2 into G. So M2 means 4 minus 2 plus 4 into 10. So it will be 2 by 6 into 10. That means 10 by 3 meter per second square. This is the acceleration. Okay. Now we determine the tension T. you can put the value of A in this equation. Suppose T minus M1G equals to M1A. So T will be M1 plus M1 into A plus G. M1 equals to 2, A equals to 10 by 3, G equals to 10. So 2 into 40 by 3. So it will be 80 by 3. So tension T equals to 80 by 3 Newton. Understand? Any question about this?
No, sir.
Okay. Okay, come. Okay. Next questions. Suppose there is a surface. Okay. Here is a mass. This is the 5 kilogram. Here is a mass. This is 8 kilogram. And here is a mass. This is 10 kilogram. And here is a copical. And the mass is hang there. That is the 50 kilogram. The mass are connected to each other. What will be the T, T1, T2. T equals to what? T1 equals to what? And T2 equals to what? Consider here G equals to 10 meter per second square. Let's start. You have to start from last step. So there is no force X along this direction. So T2 equals to, suppose this is the M, this is the M, M1, M2, and M3. So T2 equals to M3. Complete the questions. That is the T2. This is the T1, and this also the T. Okay, come on. In this direction, T2 equals to M3A. For this object, T1 is greater than T1 minus T2 equals to M2A. The acceleration is A equals to what? And for M1, T is greater than T1. So T minus T1 equals to M1A. In this that is the mg, and mg is greater than T. Mg minus T equals to ma. Okay, now so T2, T2, T1, T1, T. So mg equals to m plus m1 plus m2 plus m3 into a. So a equals to mg by m plus m1 plus m2 plus m3. You can say, sir, mg here, mg is at this direction, but normal reaction in this direction. Mg in this direction, normal reaction in this direction. Mg in this direction, normal reaction. So there is no effect on this object, mg. So 15 into 10 by 15 plus 10 plus 8 plus 5. So the answer will be 15 into 10 divided by 15 plus 10 plus 8 plus 5. So answer will be 3.947, 3.95, 3.95. So A will be 3.95 meter per second square. 3.95 meter per second square. Okay. This is the acceleration. Now, what is the T1? So T2 will be M3 equals to 5 and it will be 3.95. And T1 equals to M2A plus T2. T equals to M1A plus T1. You can put the value, then you can answer the T1 and T2. Okay, understand? Do you understand? Yes or no? If any problem, please ask me.
Sir, no problem, sir. Understood.
Okay. Now, so there is another topic. This is the momentum. Okay, momentum. Momentum is denoted by m equals to p equals to mb. Sorry, p equals to mb. Here m is the mass and b is the velocity and p is the momentum. So the product of mass and velocity of an object or moving object is called the momentum. The momentum is a vector quantity. Momentum is a vector quantity. Suppose here is the object. The mass of the object is 10 kilogram, and suppose 20 Newton force is applied on this object. From the rest u equals to 0, after traveling 10 meter distance, what will be the momentum? Okay, after traveling 10 meter distance, what will be the momentum? You have to remember this, there is P equals to mb, but we do not know the value of P. So at first, we have to determine the velocity B. And for B, we know that two equations, B equals to U plus AT and B square equals to U square plus 2AS. Here T is absent, so this equation is not valid. So U, but A is unknown here. So you can determine the A. F equals to MA. So A equals to F by M. So F equals to 20 by 10. That means 2 meter per second square. Okay. Now you can put the value here and you can B. U square plus 2 into 2 into S means 10. So that is the 40. So B equals to root over 40. That is the final velocity, meter for root over 40 meter per second. So now M equals to 10 and B equals to root over 40. So this is the answer. Okay. 10 into root over 40 and it will be 63.25 kilogram meter per second. Okay. 63.25 momentum. And there is an important topic, Newton's third law, and it is related. There is the application of Newton's third law, that is the conservation of momentum, and we discuss about from this collision. Okay, Newton's third law. Newton's third law. Sorry, Newton's third law. Newton's third law. It is a famous equation, famous law. We know every action there is an equal and opposite reaction. Action and reaction. They are opposite and equal. That means action equals to minus reaction. This is both are force. Both are force. So action and reaction acts different object. Different objects. You have to remember this. Different objects. Suppose this is the surface and there is the object. Suppose the weight is action, the normal reaction. This is the normal reaction. It is applied by the surface on the object. You have to remember this. Sometimes you know, sir, for weight and normal reaction in same way. Sometimes, but it's not always. You have to remember this. Action and reaction are opposite to each other. So, according to the Newton's third law, suppose F1 equals to minus F2. F1 equals to minus F2. F1 is the action force, F2 is the reaction force, etc. etc. Suppose this is the mass of an object M1, it moves U1 velocity, and this is the another mass of the object M2, it moves on U2. So if U1 is greater than U2, U1 is greater than U2, you have to remember this. If U1 is greater than U2, after a difference of time, they collide to each other. So suppose this is the collision time. This is the force, and this is the M1, and this is the M2. So it will be the F1, and this will be the F2. After time t, they collide to each other. They collide to each other, and after that they moves in this same direction with velocity b2 and b1. This is the M1, and this is the M2. They have the size change, but the size of the object will be equal. So this is the before collision, this is at the time of collision, and this is the after collision. Before collision, at the time of collision, and